What's up, chat? How is it going? It's been a while since I've done a session. Let me see if I'm okay, if the everything's good. I think. Do I have to reload this? I think I have to reload this. Just a moment, I'm just going to see if I have the voice ready. Seems okay. So today I will be doing kind of, we're a little bit changing the course. I'm going to be going through creating a web server with HTTP and C from scratch, and it's going to be just a simple web server, nothing too much fancy. I have an idea which I need to do, which maybe I'll just do after when I've completed. I already have a working implementation with me where I am able to parse the HTTP headers, parse the HTTP body also. And now I'm going to be going through this course, this boot.dev course. I think Prime has it. Prime was covering this up mostly. So yeah, just to see where my current implementation stands, I'm going to go through the assertion and all of that, and I'm going to see also how exactly assertion and these kind of things work in C also, if I have to make some test cases and make some edge cases and see how I can do that. So yeah, it's going to be covering that thing. So if you can see my HTTP header, I'm just parsing my header like this. I'm first taking out the control type uh, by using this str function. This finds me the character up till this, and it just returns a -1 if it doesn't find anything. Then we just return a -1, otherwise we just duplicate the string which we have found. And what we're doing over here is, generally we are just uh, kind of duplicating the string from, we're just trying to copy from this buffer that we have received, and what do we want to copy in the buffer is also crucial over here, that it I think gives us back the character or the string which we have subtracted from. So it takes in the C type position, which is basically the kind of the you can say, which is the character or the string that we tried to find. It finds the first occurrence of that string. For example, if we do this str and we want to find the first space from this character buffer, then it's going to give us back the space and also the character itself to which the first space is there. So what happens is that now once we have the space, once we have something like the get, the control type, because the HTTP packet header is something like this. So post, and then there is a white space, kind of a space over here, and then there is a delimiter and space again, and the protocol itself. So we just need to, for to get the control type, which is going to be the post, we need to find it until the space, and it just this str function gives us back something like this. It doesn't give us this slash, but it gives us the space and the post itself. So we just subtract it from the character buffer, and then we get the we just subtract that part from the character buffer, we get the post, and we just save it into our own struct that we have already. This is generally the idea. This is how I have mostly covered it out. And yeah, so wait, let me just okay. And yeah, so I'm just based on that, I'm just trying to parse different kinds of things, like for instance, if I can show you guys that I'm just trying to parse, and then I increase the pointer of the buffer to make it point to the next step, just +1 it, and just I don't, because once I do have this, once I have this like the post, I want the buffer to move towards over here, right? So I'm just doing the character length for that, and +1, which moves it to the next bit, and it's going to move come over here. And if I go and show you guys over here, now we're having the second space over here, we're targeting the second space over here, which is going to give us the path kind of, like what is the path. I'm just going to have, it is going to be slash, it can differ, I think this is going to, we just need the path, so slash http 1.1, I think that is the path. And then we get the protocol. For protocol, we target, we move forward and we target the new line and the new space, like crlf, the crlf itself, and we target that, and it gives us the part from here to here. This is basically what it gives us. And so we just do the same thing, and but this time we move the bit to twice, because we need to go on to the next line also. And for host header, this part, we have a different kind of mechanism. First we're fetching, because we don't need the host itself, we need after the colon. If you can see the host over here, we need the part, this part, we need to remove this part and have only this part for us. So what we do is we just first search for the for this, and we then see if we have the host header. That's fine, that means that this is correct. And then we just plus equals the current header, which we current character or the string that we had searched from, and we just add the length of this, so that we move so that we already have that part which has the host, colon, and the space. It's all added into the old character itself. This way we can search for another, we can search for on this host header itself for the crlf, so that it gives us, it goes over here and gives us the part before that. So, and then we simply just do this, we just remove the end part, which is this part, and just remove, just we fetch this like this. Oh my god. And we basically, what's going on, we just subtract this part from this part. That's it. So that's what we're doing over here. And similarly, if I go with the body, if I go into parsing the body, I'm doing a similar thing over here. I'm just trying to fetch the content length. I add the content length, I just add everything up till there, and then I just do str and duplicate. I think this is spelled like this. Return a malloc copy of at most n bytes. The resultant string is terminated even if no null terminator appears. Yeah, so content length and minus content len, just remove the end part, just remove the content len colon space part from the actual content len, which is going to be the c/r/n. And yeah, similarly we have the body also over here. I'm going to show just one thing, and it's going to be, so if you can see, we have the body. This is all coming from the packet struct that I have created, the content length, the content type, and everything is coming over here. So I'm just going to do one thing. I'm just going to remove this from here, and we can do something like this. Packet control type, packet protocol, and what else is there? I think content type, content length, it's going to be body, right? Body, content length, and content type, right? This way we would know. Right, so control type post, packet protocol, application, content length, param, everything seems to be okay for us. Right. So moving forward, I just need to see, I need to apply some test cases. I'm too lazy to just read through all of the RFC. I have read through some of the RFC, but it's just too detailed, and yeah, it's good to read, but I just want to, just get done with this maybe. And so that's why I decided to just build up the parser and do everything, just get an experience of how it's done without looking at any course or something like that. Just understand how most of the things work in C, because this course is Go based and I'm working with C. So I just wanted to see how it's going to be done in C, and just understand a little bit of the syntax and all of that, and then we can move forward with looking into something else. Yeah, so just one thing I need to do. Yes, okay, so we should start. I think HTTP streams, we're too far ahead, we're in the HTTP body. I don't want to go there right ahead. Welcome to the startup 8 bytes new line channel refactor. Okay, TCP, we have already done the TCP part, and we're going on to the request part. So the TCP part is already done. Obviously I have implemented the TCP part over here. If you can see, we're using polling currently. I'm going to be building an event loop in this for this also, because I think my whole goal is to build a web server which is going to handle lots of traffic, and not because I want to maybe launch something like that, but because I want to understand how the event loop and polling and heavy traffic work. This is a very basic implementation of an of a TCP listener, where you just poll through the request, and but it's very slow because it's O of n, and it's not O of constant, it's on, and because it loops through all of the array. For instance, if you have 1,000 connections connected, it's going to check all of the 1,000 connections and see if any of the connections has their R events property set to 1. That way it knows that okay, this particular connection has an update. So it's a lot a really lot overhead for the memory and for the computation as well. So we're going to change this. We're going to maybe use something like epoll, which is generally designed to handle a lot of requests at one particular time, but we're going to also build an event loop on top of that using that epoll. And yeah, we'll see. I still need to complete this so that I'm able to accept and send a response back to HTTP request, so that I can benchmark the HTTP web server and see how many requests I will be able to handle. Anyways, so moving forward, I'm just going to see TCP to HTTP. HTTP works because plain text is binary, because your response is too big to fit into a single TCP packet, can be broken up to into many packets and reconstructed in the correct order. On the other, TCP guarantees that the data is in order and complete. It's going to it works because as our response is too big to fit into a single TCP packet, can be broken into many packets and reconstructed in the correct order. RFC 2.1 message format. An HTTP message consists of a start line followed by a CRLF and a sequence of octets in a format similar to the internet message format. Zero or more header field lines, collectively referred to as the headers or the header section, an empty line indicating the end of header section. So this is generally the format where we have the start line, we have a CRLF, and then we have a field line where I think fields are defined like content type, content length, transfer encoding, things like that. And then we have another CRLF, and then we have the message body itself. The start line basically includes the method that we have, the post method, and the protocol, the path, and then there are fields. So mostly headers have the most important part in, like for instance in a GET request also, it's going to be the start line, the path, and the field line, like if it has. I'm not sure still how query parameters or all of that. I think they are going to be coming inside for us for in the path, right? So I'll have to see for that also. Message can be either be a request from client to server or response from server. Syntactically the two types of messages, which is either a request line for request or a status line for line, and they're working different than the short line. Message can either be either a request from a client to a server or a response from server to syntactically to on in start line, which is either a request line for request or a status line for an in the algorithm for determining the length of message body. Yep. Start line request. Okay. 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 Message parsing. The normal procedure for parsing an HTTP message is to read the start line into a structure, read each header file into a hash table and by field name until the empty line, and then use the parse data to determine if a message body is expected. Hash table in C. Let me see. I think it generally means kind of like this, where you define a struct and you add it right, struct character key, okay, items, okay, character key, right. Look, I can see I already have a struct over here where I'm not sure. I don't think it's a hash table exactly, but it's a struct that defines my HTTP packet. I think this would be sufficient enough for me. Let's see. CRLF written in plain text as slash is a carriage return followed by a line feed. It's a Microsoft Windows and HTTP style. I calls slash r registered nurse. Okay. The order registered nurse. Okay. Let's break down each part. Start line, post users. Oh yeah. CRLF. Okay. The request for a request. For a request or status for a response line, field line, host Google, yeah, zero more lines of HTTP, either these are key value. CRLF, a blank line, that okay, message body, the body of the message, and this is optional. Okay, both HTTP requests and responses follow the same format through the contents of each section. Okay, responses follow the same format. Redirect the output to a temporary file. To be clear, here at the startup we build HTTP up to date serious software or impossible. Okay, to understand it maybe behoove you to become familiar with request for comment. At the moment there are several key RFC active and widely referenced, easier to read than RFC, even to don't understanding from RFC covers. Okay, now you currently the command line tool for making requests. If you cat the file, you should have something similar to this program from the root of your redirect output to a temporary file. No, I don't need that. I just need to curly probably. Okay. Testing with testify. Okay, so this is the part I think where I need to write some test cases, maybe custom test cases for myself to just check. No complex logic in my test, please. I'll explain my approach. In Mozilla, we encourage the user standard level testing and Xnetflix as a different preferred approach. So I prefer bigger tests, higher level to smaller tests, tiny units, because it means I can refactor my code base more aggressively without having to rewrite a bunch of tests. I don't write tests for every function. I write tests for function that I'm unlikely to get right the first time. So completely lots of I keep my tests simple and declarative. Point 3. I've also seen like in a lot of places in C where test cases are written that the test cases are done this way, not this way, but this way, this particular way, where the assertion, I'm not sure exactly. I will understand this now more. I will be diving into this how I can do something like this. So I think this is going to be generally the function, no, not the function. I think maybe the function that we're testing, strings new reader, or maybe this is the std in for us, not sure. Let's see. Conditions, fewer things for me to get wrong. We'll be working on the request line parser, so let's get our directory structure and test dependency. A directory and a request directory, and the file declare it's part of the request package. Our test will go here. Install the create a request test go file. It's also part of the request package. Our test will go here. The dependency in it is simple test that doesn't test any application yet, but ensures you have testify set up correctly. Okay, so I think he's asking for kind of a library, for assert library. I need to see. I think I have something. Uh, which had test cases, right? So something like this. I'm not sure what they use, but something like this I think is going to help us out. Hmm. Where does it go? Assert true in C. Not sure. Hmm. Hmm. Let's ask GPT about this. What is this? Assert library in C. Hmm. C Mocha. Oh yes. Oh yes. C Mocha. For C with support for Mog update only requires the standard C library works on a range of computing platform including embedded and with different compilers. Uh, where do I have it? Where can I have it? Where is the documentation for this? GitLab? Let's first understand how the standard library assert functions work, and then we can see into this. Maybe I need to see how to write test in C. Assert in C. Okay, let's see. C library is, when should we use asserts in C? Let me see what the Stack Overflow has for us. Assert aborts the process, but it is turned into a no when the program is compiled with nothing more. You should only use assert to check, but that can't happen. That violate invariants of an alpha, but probably not for input. Okay. Well, user could be you've implemented an incredibly smart sorting algorithm and you want to check whether it really sorts. Supposed to just work and therefore doesn't return a value. Hmm. So this something does something different. Mm, this is kind of input validation testing and things like that, right? I don't think assert is going to work for us for this. So alternatives for testify in C. Wait. Need to have something like testify, which is in Go, but I am working. Let's see. I think I find AI, I use AI like this to get the definitions and the understanding. I think it's a very good way to understand and use AI when you're not asking for solutions, but you're asking for definitions and you're asking for things that you want to, that you would have asked, I think, Google in the past. And I think it's a good way to it's more efficient because Google gives you a lot of results and you have to go through all of that, and there's still uh, you won't get the most relevant kind of information out there, but yeah, you do get some kind of additional information. But Google's search engine has been a very inefficient, I think. These days it just doesn't give that good results anymore. And I think, yeah, so you can leverage AI or ChatGPT, something like ChatGPT, for things like this where you want to know like how a testing framework works, what kind of thing it does, and things like that. So I use AI like this. I like it, and it's good. It doesn't mean that I'm potentially completely relying on this. Obviously you need to find some sort of information to look into it, and then you can, just do your research. So it's kind of a starting point for my research, and then I hop onto the maybe the library itself, go into the code base itself, and see what kind of information it gives me. Looking for a testing framework that feels a bit like Testify. Okay, works like Go. From there you can compile and link with LC Mocha, then run you. I don't think I need to tap into things like this. I think I would be good with C Mocha. Let's just explore this first, what C Mocha has to offer for us. Compile a C Mocha example run, create a build directory, and in the build directory call cmake part to C Mocha followed by make. On Windows you can use cmake GUI. I think I need to compile it somehow. Maybe using cmake. Let's see. Let me ask it. I need to install it as a binary, I think, first, and then I will be able to use it somehow. Or does C have some sort of package management? I'm not aware of this. Let me see. Yeah, I'm sorry, depends on the OS distro. Yes, it in C you have to actually have that particular library that you're using, and only then you can use. Okay, C Mocha Arch Linux. Okay, okay, really. So if I do something like sudo dash s c mocha, okay, so this is okay. I can just directly install it. Huh. Sorry. Let's just create something like http dot and in unknown type names IST. Too many errors emitted. Stopping now. do something like this. Okay. I'm just going to follow. Hmm. Let's try this. Rest edition. Okay, seems to me that this is fine. And we can start with this, I think. Yeah. Let's do one thing. By building on top of TCP, we already have code that handles plain text data. Now we just need to already take that plain text, turn it into structured data, ensuring that it follows the HTTP protocol. Okay, to return a struct that looks like this. That way our application, the server code, is nicely structured HTTP data. Start line according to the RFC rule. Remember that. Request, not a response. Then the start line is called. Okay. HTTP version. For all the positions, but for it, it's pretty simple. West line looks like this. Okay, for now we're only going to parse the request line. Remove your useless assert from the request instructs to the request dot request test code or file. Step out a new, it's still better than public static void main. Okay. Step out a new function with the signature function request. Okay, I think what we have to do is we need to so as I said that this is the function that I think it will be testing, they will be testing, and this is the input that they're sending in. So we need to do something like this also, and test good get request line. Okay, and I think we already have our function over here, if you can see, which is parse http header. And what does it request? Okay, the request struct represents a full parsed, but for now we'll just be working on the request line. So it basically returns a struct of request, right? So it needs, okay, r require not nullity, r request line dot method. Okay, okay, so I think we can do, I'm not sure. Firstly, I'm just going to make it like this and make it this like this, and just do something like parse http header. It gives the packet. We can return the packet itself, but we're currently returning an int. And mm, so we can do, can we do, but it's not going to work through that context, right? Is packet something we're allocating on the memory itself? Even if we allocate it on the memory, it's going to cause kind of an issue. We would need a kind of we would need a return struct in this, because otherwise it's not going to work fully. So okay, let's do one thing. Let's make it return the packet, right? um Sorry, I have something like http packet. Okay, and I'll have to change this. So what is their return type when they're, I think they're sending, the return types are kind of different in this, and we would have to work our way through this, something, doing something like, if I try to, let's do this. Let me just remove this, and right, and I can do, okay, from a version with the reference with, okay, we need to return the http packet itself, the value for that. And now we can do something like, it's going to be static void test edition void state. Does it have a void state with this? Okay, I think every function has a void state with it, and it's a static void and the function name void state. Okay, test framing connect. Okay, and let's do this. It's going to do HTTP headers, and it's going to generally assert what? It's going to assert as assert int equal require no error t error, okay, require not nil, okay. Let's see Mocha API. Mm, expect string, I think. Assert true. I don't think it has a require. Hmm. I don't know again. I think I need to fail my function also. Hmm. Yes, I think we can create a struct here also to just to check our packet. We don't need to do something like this. I think we can do, we can just do, right, sorry, and we can just have our struct, which is this, right, sorry, right, and then I can do we have this function, sorry, I also need to include main.c, right? How do I include the main.c file? Do I need to create a .h file? Can I include .c file in C? Okay, main.c, is it doable? What's the problem? Main.c including another file.c. What happened? Let's do something like this. I don't have a test edition. Ah, so this is the problem. If we include the main.c file, it's going to just uh, bash us out. So oh, it's now giving error or on int main. It's fine. Let's just create a file with http.h. No, yeah, I think it's fine. http request.h, right? And I'm just going to write to this file, and I'm going to have this file et, and we can have something like this, right? I don't need to have this. Do I need to have this? Yeah, it's fine. We can do one thing more. We can do something like this, paste it over here, and we can just have main, right, included over here. http http request.h, a file not found with angled, include use code instead, fix available. Okay. Need to do something like, but it should come, right? Like if this particular person is okay. Anyways, let's just skip to the, I'm just going to try and compile it, and dash o exec. Does compile. I'm just going to see once that I have the correct, no, I don't need this one. Right. Yeah, I just try to make a request and don't have any. Should give me this, right? Port 3001 after 0ms could not connect to the server. Okay. Seems to be a problem. Okay, now it works. For some reason it was not working. Now it works. I think I did not have it saved, or I don't know. So we're just going to do, we're just going to add this also, and we're just going to include, what's that, I think it's going to resolve our problem. And we don't need to create this also, right? What can I do now? I need to test the with a couple of characters that I will be directly sending inside the function, right? So I do need something like character request, and it's going to be yeah, right. And then I need to send it in the function, which is going to be parse http header. It's going to have the request, and it's going to have packet. So the packet I would need to create, right? Let's see. Something like this, right? And now we can do assert true, no, Let's try this. Undefined reference to parse HTTP header. What does this mean? It's going. LD returned one exit status. It's creating the function over here, but I have already linked to the function, right? So it should work for me. What could be the problem? Hmm. Hmm. What is s.c? Let's just see. Hmm. So it's saying to add the extern keyword to the function definitions. Like, I don't know, extern, something like this. Uh, doesn't seem to work. Let's do one thing, right? I'm just going to copy this. And let's not include this. Let's create a packet of our own. Hmm. Doesn't give me anything. Okay, so let's try with something else. Let's try with a failing thing. It should give me mm, right. Okay, still works. Our function still works. Good get request line with path. It's not working, I think. I'll just confirm it. Where I have, so we can do something like, and we can do paste it over here, pass in the request, right? And see gcc main.c -o exec. Sorry, I'm just going to check and see. Okay, so it doesn't work. It actually has an issue with this. Uh, it just sets the packet control type to this. The fucking problem over here is going to be is that I have to update the function 2 times. I'm thinking I just do it something like, I don't know what could be the solution for this. Let me see. This is very hectic. Undefined reference in error. I have been able to reproduce using the following. I think we can. I've not tried adding a compiler file over here, right? This is fine. This is fine. Right, and I can do something. First defined here, multiple definition of main, and let's see if I can come up with something like this. The problem is that you're including commander in commander before the function progress. It inserts the content into commander before the command. As a result, the function definition ends up before the function declares, causing the content before the behavior phase looks like this. Okay. This is an error because you can't declare a function after its definition. If it's swapped, includes command and the function declared, and the error shouldn't have it because now the function loading.c file is the brand and should be avoided. A better solution for this problem would be to include command and link the compiled version of the command to the main file, for example. I don't know, man. Undefined reference to HTTP header. Still this gives me undefined reference to. Let's ask GPT to I have a main.c file, and I think I have another file, main.c file, and coming from it gives me int main already defined. How can I resolve this situation? So this is also, I think, kind of giving me to do make the file structure. I don't want to go through that. Maybe I can just test in the main. But it's going to run the server then now also, right? Not going to compile properly, compile separately. What did it even change? Okay. Let's HTTP. Let's write the file and let's have our function. Let's have both of these function. Over rewrite, and I'm going to just do this, and so going to this file again, and I can do, is it going to work? It's not going to work, obviously. So I need to include the main file also, I think. Include math.utils.h and utils.h. So we're going to do something, request dot I already have this. Let's do one thing then. Parse HTTP parse. Okay, so it's giving me the error on this. It's fine. Let's see. This is fine. We are doing fine. We're doing fine. We're doing fine. And if I try to huh? Handle client data. Okay. And I think we need to have this. Uh, um, it's going to include the .h file, which is okay. We're including the .h file, right? This is okay. We're including this, and it should go inside here. And now my is going to the correct function, http request.c. Still says parse http header. I don't think it should give me an error like this. Uh, mm, I have a couple of projects over here which works completely fine. Main.c has right, and gc.c has all of the functions. So it should be similar to this. I have my mm, I'm not abstracting away the server logic at the moment. I don't want to do that. I just want to make it work somehow, but I have included the, if I can see, uh, this main, it includes the gc.h, which is, I have also included the gc.h. Maybe I have not written to some file. Is that possible? I don't think that should be possible. Function call parse undefined reference to parse http header. Let's do this. Doesn't work. http request.h. No, doesn't compile. What could be the issue? Doing everything. Let's just so you know, maybe mm, handle client data, process connections, tc.h. using the by including it gives okay, I think I need to compile them. This doesn't happen. Main.c. Mm, mm, and I need to do HTTP. Okay, so I had to compile it separately also, link them also. I think this can be done inside of a make file. So let's look into the make file. I think I have to look into that because I cannot call this whole scenario go to test point. See, how are you doing the compiling? You'll need to specify both files, something like so that it knows to link the functions from both together with the code as it's written right now. However, you'll then multiple you need what to eliminate. Okay, so now I have this. I can do something like uh, let me just bring the test.c, right, and test additional undefined reference to assert true. Okay, now I have something new. The function undefined reference to assert int equal Now there is a problem with this. Let's just do something like this. Test edition. CMOCA undefined reference to. What the hell? In function test edition undefined reference to assert in equal in function main. CMOCA. I need to include LC Mocha also. Yes, 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 yes. I'm sorry. I'm sorry. I'm sorry. And we can do something like okay, now we have the correct output. Failed. So I think we're getting a -1 from the function, which is correct. I can check this in mm, sorry. Mm, How am I testing? It's not working with this also, right? No, we don't do this. We need to do assert int equal a to the largest. Let's not do the int equal one. Uh, should be able to do that. Let me look into that. Packet dot HTTP 1.1 is not equals to get. Okay, works. I need to do mm, so I can do something like control protocol should be HTTP, right? And we don't need to check the host itself. I can check the path. We're not having the path correctly. This is good. Okay, we can do some things with this. Okay, we're going to continue this. I'm just going to take a short break and I'm going to come back and we're going to grind it a little bit more and see how we can improve our parser and just do a couple of updates in it. Okay, so until then, you guys take care of yourself and yeah, we'll be back hopefully. Keep bashing to bits. Bye bye.